All right, so we were just talking about pan balances, and you can also use hanger diagrams as well. But so we're going to solve equations by reasoning. So if we were to reason about 2x equals 6, we would think 2 times what number is 6? The solution is 3. Another way is that we could divide it. We could say that x is equal to 6 divided by 2, right? We could divide both sides of the equation by 2, and we would get 3. Now, to solve x plus 3 equals 7 by reasoning, we would say, well, what plus 3 equals 7? What number plus 3 equals 7? And the solution is 4. And then we could also solve it by subtracting the 3 from both sides. So in these examples here, we are going to solve each equation by thinking about the expressions on both sides and reasoning about what would make them equal. We're not going to use standard algebraic techniques. So these can be a little tricky, so let's just take them one by one. So we've got x plus 57 plus 94 equals 98 plus 57. All right, so I do see a 57 on both sides. So when I look at this, I think, okay, these 57s are already equal. So I need to get to the 98. Well, what number plus 94 would get me to the 98? So if I were to add 4 to the 94, it would make 98. So x is equal to 4. So this may be a little challenging at first, so just take your time. All right, let's look here. We've got 57 times 94 plus x, and then 58 times 94 plus 3. So let's look at the differences to try and balance this out. So here we've got 58, and here we've got 57. So we need one more group of 94. Again, group of 94, because we're multiplying it by 94. They're both being multiplied by 94. So we need one more group of 94, and that would make 58 times 94. Then those two would be equal. And then, so that means that would be equal, and then that plus x would be the same as plus 3. So that means x is equal to one more group of 94 would be 94 plus 3. That 3, we would get x equals 97. Let's try another. We've got 487 plus 176 equals x plus 490. All right, so now we want to get to the 490. We don't have 490. But if we were to take, how many would we need to get that to 490? If we were to take 3 from 176, that would make 487, 490. And then that would be 490 plus 1, and we took 3, 173. And then that would mean that x equals 173. And these can be kind of fun if you think about them as puzzles rather than trying to solve these algebraically using standard techniques. So go ahead and give these a try. Really try all 3 and then press play when you're ready to see the solution. And there we go. So now let's actually look at a pan balance. So if this balances, what about this? Will it tilt to the left or to the right, or will it balance? So let's take a peek here. Oops. So if this balances, what will happen in this case? Will it balance? So let's look. We had 2 x's and then 2 sets of this here. And so we just took half of this. Did we take just half of this? Did we do the same thing? Yes, it's going to balance because we took half off of both sides. So now you go ahead and give this a try. If this one balances, what about this? And explain your thinking. Press play when you're ready to see the solution. And there you go. We divided by 5 on each side, and because we did the same thing to each side of the balance, it will continue to balance. So what is the reasoning behind the methods we use to solve? So how do we solve? The pan balance view, a lot of times you're going to see hanger balances as well. So like a hanger balance, you know, is going to look like this and this, and you're still balancing. And the easiest way to solve equations, like x equals 3 and x equals 2 or 5, because they tell you what the solutions are, but sometimes they get pretty messy. So we're going to actually do a pan balance. So when we think of using reasoning to solve, we've got this step-by-step, and we're going to model it the same way with the pan balance here. So here's this example. We've got 4x plus 2 plus x. So 4x plus 2 plus x. And then we've got 3x plus 3. And then we're going to reorganize on the pan balance at the same time that we combine like terms or make equivalent expressions. So 4x and x make 5x. And 2, and then 5 plus 3 make 8. And so we just reorganize the pan balance over here. Now here, we would take 2 from both sides, and here we're going to get rid of these on both sides. We're going to take 2. We're going to eliminate 2 on both sides. And so we're left with 5x equals 3x plus, we still have 6. So now we want to get all the x's to one side, so we'll take 3 x's here, and we'll take 3 x's there, again, algebraically and pan balance. And then we're ending up with 2x equals 6, and then we're going to divide both sides. Now here, it's telling you, okay, each x is balancing 3 of these. We've got kind of think of these as in half. So we end up with x equals 3. So let's just do one together. So solve the equation 2x plus 4 plus 3x equals 6x plus 2. So starting with equations, we've got 2x plus 4 plus 3x equals 6x plus 2. So that's going to be x, and we've got 4, and then 3 more x's. And then over here we have 6 x's, x, and then 2. All right, so let's combine like terms. So I'm going to keep this equal sign going like this. So 2x and 3x make 5x plus 4. And we're combining. We're changing to an equivalent expression. And then here, we didn't change anything. So here, we're just putting the x's next to each other. So 1, 2, 1, 2, 3, and then we've got the 4. And we didn't change anything over here. Okay, so now let's take a peek at this. Maybe we'll take 2 away from both sides. So we would get 5x plus 2, and we would get 6x. So if I took away 2, I would get, oops, that should have an x. I would have 1, 2 left over here. And then I just took away 2. I would only have my 6x over here. Okay, so then what might we do? We might take 5x from both sides to get them together. So then over here, I'm only left with 2, but here I'm left with x. So I take 5x, that's all gone. And if I take 1, 2, 3, 4, 5, I'm left with x. So I can see that x equals 2. So go ahead and give this one a try, doing the same thing. Press play when you're ready to see the solution. And there we go. So what is the reasoning behind the methods we use to solve equations? So pan balances are great, but they don't work well for all equations, just for some. So in general, it's good to have multiple ways to do it because there are some funny kinds of equations. So when we change equations, we can use properties of arithmetic. Basically, saying to change an expression on either side, changing it into equivalent expressions. So here we would say 3x minus 4x is the same as this. We can change expressions by adding or subtracting on both sides, which we saw, right? As long as we add 2 here and add 2 there, we're in good shape. We can also multiply and divide on both sides as long as it's not 0. Here I can say divide by 5 as long as I divide by 5 over there. And then there are some special cases when there is not a solution. So 3 things can happen. You can have no solution. When I subtract 2 on both sides here, and then I subtract 3x, I end up with 2 equals 0. That's no solution. Here, when I subtract 4 and then I subtract 3x, I end up with 0 equals 0. This is false, so it's no solution. This is a true statement. But when I still have a variable and it equals a value, I just have one solution. So a couple different things can happen. Let's look at this example. So we're going to solve these equations using the standard algebraic process and just interpret the outcome. So I'm going to use an equal sign line. And first, there's nothing to do over here, but over here I need to combine. I'm going to put my invisible 1. So that's 3 x's and 1 more x gives me 4x plus 5. And I'm going to subtract 5 on both sides. And I get 5x plus 2 equals, and that goes away, I get 4x. Now I'm going to subtract 5x on both sides. That goes away, I get 2, and 4 minus 5 is negative 1x. Now you could multiply or divide by negative 1, and we're going to get negative 2 equals x. So x equals negative 2. And that's one solution. What about this one? 5x plus 7 equals, we're going to combine these two, we get 5x plus 5. We're going to subtract 5 on both sides of the line. So we get 5x plus 2 equals 5x. Now I'm going to subtract 5x on both sides. You might be saying, uh-oh, something weird is about to happen. And we get 2 equals 0. This is false, which means no solution. If this had been a true statement, it would be infinitely many, but we get no solution. Go ahead and give this a try. Press play when you're ready to see the solution. And that concludes section 9.3.